Hey there everyone, Hitesh here. Good morning. This is 5 o'clock in the morning and turns out couldn't sleep. So I thought, let's record a video. And this reminds me, it's so much important for me that for some days I need to just get rid of all the tech so that I can get myself back and don't feel the burnout. But anyways, I'm about to take a break. But anyways, this video is another engineering side of the video. And it turns out a lot of people are these days coming up not from the formal computer science background, but from a different variety of backgrounds. Even some of the chefs and accountants are coming into the programming world, and they don't truly appreciate the engineering side of it. And that's why I'm creating these sets of videos. Again, these videos are not 100% of my own. They're coming from a lot of books, a lot of blog articles, a lot of my libraries in my college as well. These are common knowledge. Everybody knows them, but a lot of people turns out don't know this. This is another video in which we are going to discuss a lot about the database. I'll spark enough of the curiosity in you so that you truly understand what it takes to make a database and why there is a database war going on in the market. I'll spark enough of the question inside you that you will now question every inch of the database, and you will be able to truly understand that what makes database a good database and how you can select a database for yourself. Although this is generalized, I'm making this self here, but this is a generalized database engineering side of it. It doesn't mean that this is a side of MySQL or Postgres or MongoDB or any other database, vector database that you're working, probably a separate video on the difference between them. But first, this is a generalized side of it. Not only that, this video will also give you enough of the details so that you, in case you are curious about the blockchain and what makes blockchain, you will get a tiny bit hint of it. So for all the enthusiasts in the blockchain, this is the video. So welcome back. Hope you have already hit that subscribe button because these days I'm onto a spree of making videos and I should really stop it down. I should really. So let me walk you through. So first of all, a couple of questions before we go and embark the journey of what's a database and how does a database system entirely works, what's the inner engineering of it, what are the different components and the parts which are stitched together to make it work. A couple of questions to you. Have you ever wondered and asked yourself a question that why should I choose a database and what's the importance that database is giving me? What's the difference between choosing a MySQL and a Postgres? Both are relational databases, but what makes them different apart from claiming of the speed that they give us? Or why should I choose something like a MongoDB instead of a MySQL? Okay, it's a document database, but what makes it a document database? Also, have you ever asked yourself a question that, hey, whatever the database is doing, I know that it's writing something inside the disk. All right. So whether you choose MySQL or a Postgres or a MongoDB, it ultimately writes it inside the disk itself. And that writing part is a little different. A relational database obviously writes it into a tabular format, like an Excel sheet, or databases like MongoDB, it just dumps it out into the object format. But once they actually put it into the file, ultimately what the file is, it just is a sector on your disk, whether your SSDs or hard disk, but it's engraved there, it's magnetically written there. So how does these database actually gets that update facility? How they are able to go inside the disk and actually rewrite that sector? Because if you have studied any computer science, that's not possible. Once that's magnetically engraved, that's it, tada. It needs to be wiped off and completely rewrite that. There is no update facility in the drive. So that's where the engineering side of the things actually spark. And that's where I enjoy the most that, hey, how come this is possible? And that makes you a real engineer. So anyways, I hope those questions are very interesting for you. Let me take you onto my iPad. And again, I forgot to spin up my iPad. Just give me a second, I'll spin it up. Not really a big deal. Should have done that already, but hey, it's 5 o'clock in the morning. You can excuse me for that part. Okay, let's go ahead and start with that. Come on, spin it up, spin it up. There we go. This is our database. Yes, I have already curated a diagram so that we can focus on just the talking part of it. And when I actually write it in the videos, I just write it in the very fast phase. Ugly handwriting spins off. Okay, so let me just walk you through one by one. You don't have to worry too much. This is all manageable. You will understand a lot of it. Not whole of it, but a lot of it. So first of all, this is your ORM part or a ODM part. What is this? In case you have heard about these days popular MERN stack, be a MERN stack developer, you use a library there known as Mongoose. Now, using a Mongoose is not really compulsory. What Mongoose is technically an ORM, a representational, a client which makes my life easier. I can go ahead and directly interact with the MongoDB client or the MySQL client, but the interaction and those default drivers are not so easy to manage, understand, and they don't provide me tons of facility on top of it. That's why when I want tons of facility like Mongoose, and there are MySQL versions of it, I use or prefer to use ORM just to make my life easier, but there is no compulsion like that. For example, if you have ever written some code in C++, there is a library crow. There is no such ORM for the crow if you want to interact with the MongoDB. You have to use the MongoDB direct client, and that's also fun, but it doesn't give you that kind of validations which Mongoose gives you. But hey, that's the part of it. So again, ORM talks to the client and client talks to the database itself. That's why a lot of people, you'll see that if you read more articles, by the way, I'll probably share, if you put that in the comment section, I'll share more resources about where do I study a lot of these things and where do I get all these debates as well. If you're interested, let me know in the comment section. So that's why you'll see a lot of people debating about that there is no point or no advantage of using ORM. Probably you are using just to make another bottleneck. You should be directly using a client because at least one layer is skipped. So that's interesting. So this is the part which is used for talking to the client. This whole big gigantic thing that you see, this is your database. MySQL, Postgres, MongoDB, yep, they all have these components in that. What's interesting here is at the bottom here, that is your disk. That's where the magic happens. And a lot of database are fighting on different segments of these database. That's why you're seeing there is a database war right now, almost a war. Some are fighting on how we are going to move the data to the disk. Some are fighting over how we have actually changed our CEO. Yes, database execution engine. That's known as their CEO. Some actually says that, hey, we have actually rethought that how this index file works. That's their whole USP is. There's a lot of thing going on. So let me just first walk you through what happened. So once you have actually gone through with the ORM and the client, there could be any one or there could be both. So once you have done that, you have written some query for that. Whether that query is .find or that query is select star from users where first name equals to Hitesh, whatever that is, that's a query. And that query, first and foremost, always hits this portion of the block. Some database tools will say that this is not 2, this is just 1. Some will say this is 3, some will say this is 4 part. But the whole idea is there is 2 segments, 2 parts in which it is divided. The first one is the parser part of it. Another one is optimizer part of it. The parser exists in every language because you're writing everything in the characters. Nobody understands select star. What does that even mean? So in that case, we need a parser agent. What this parser agent is, it converts that into AST. That's basically like saying an understandable tree structure. So there's a parsing that happens. If you have watched the previous video, I've talked about that in the browser one. In case not, that's okay. Parsing simply means I want to convert that into tokens. All your keywords like if, else, select, where, equal sign, and .find, all of that are tokens. So I want to extract the tokens out of it. Then I want to run through it with the syntax and semantics, whether you have written the proper syntax, have you have a typo, whether it's according to my structure, like you cannot write find Hitesh, where username. No, there's a sequence of it. So all the semantics should be proper, all the syntax should be proper, and then I will convert that into a tree. And that's why a lot of people say learning data structure is good because a lot of things are being converted into tree, but those people are mugging the data structure so much that they forget to show you the impact of what the impact actually is of the trees. So everything that you write, whether that's C++ or your data structure queries, are converted into tree. Now these trees are actually being thrown at the optimizer. Now this optimizer is really, really cool guy, and it always talks about the cost part. And this is like in your company, there is always an accountant who says, why you bought this? Why you are paying 3 lakhs to this guy? Why you're paying 30 lakhs to this guy? Yeah, this guy always talks about the money part. But in the database, it's not literally the money. The cost could be different parameter for the database. For example, it could be faster execution. It could be don't do execution twice. Or it could be I can grab the data faster, but that will cost more. So there's a lot of optimization that needs to be done. Optimization has no strict definition. For some, the optimization is time. For some, the data optimization is execution speed. There's a lot of variables, and this is where a lot of database actually fights. Yeah. So database first is getting parsed and then it is being optimized. Now, in every single database, there is this execution engine. This is the CEO of the database management system. This decides that how the client request will come and how I will send it back as quickly as possible. Just like the CEO, consider this as an Elon Musk of the entire database. He wants to do everything super fast. Now it will push the optimizer, give me the data fast. It will also go ahead and ask, hey, how can we retrieve the data back from file? All this happens, this is the master of the ship. Hey, everything happens with me, through me, and I should be aware of everything. That's the whole job of execution engine. It doesn't literally do everything, like it does some stuff, but it doesn't do everything, but it actually asks everybody to do things faster and faster and update me. Then there is a cache as well. I'll come back onto the cache in a minute, but you don't have to worry more on that. Now, there is another block here which has a lot of utilities, and every single database company try to increase their utility function more and more. The basic one, of course, includes the authentication, the authorization, the backups, metrics to track, metrics to evaluate, clustering. Every single database company is trying to use. These are known as utility functions, and every database has their own utility. Probably I'll make separate videos for MySQL and MongoDB where I'll walk you through these utilities which are separate for each one of them. But hey, this video will serve as a base guideline. Now, coming up, now remember one thing. No matter what database engine you're using, you're always getting the data from the disk, which is a costly operation. It's not easy to invoke your kernel and grab some data and get that. So every single database has this cache operation that, hey, if this operation or if this data is frequently being accessed, let's not always call the kernel and rather put it into the cache. If we have that, and again, the cache is exactly same as you study in your OS, that hey, there is a page, and if we get the page hit or a page miss, exactly same. So you get the cache. If that is there, your CEO always asks the cache first. Hey, this is the query. It is being parsed. It is being optimized. So do we have the access in the cache? If we have the access to the cache, throw it back to the client. Don't even think for a second. And on top of that, these utilities always runs based on there is a need or not. Like for example, whether you are authorized to ask me that question or not, whether you are a like reliable client or not, whether there should be a timely backup of this data or not. These are utilities, so we are not bothered much about it. Now, what we are bothered about it, where a lot of database are fighting these days, is this block. So there are two portions of how your data is going to be magnetically engraved in the database. The first one being the data file, and the second one is index file. Now, your data file is actual data. There is nothing in it. And yes, there are debates and there is competition on that. For example, some data files should look like tables and rows. That's what the relational databases are. Some says the data file should be written in the document format. There are vector formats even. So this is where a lot of fight happens and a lot of variety of the database is given to you. That, hey, I will be able to extract the data faster if you just give me that document back, and I'll do majority of stuff in my execution engine. Or some says, hey, let just execution engine handle the part first and then go to the data file to specifically look for rows and columns and get only that data. Again, debate, good debates. And the index file is actually the metadata, because if you notice, if you have ever gone into the MongoDB Atlas, you'll find that there are different indexes that you can create, and these are searchable. Like, obviously, you're not going to search directly from the data file. There should be some metadata, data about the data, so that you know how to find the data which I'm looking for. And that's where some people say that, hey, we'll have just one primary index, secondary index. Some says we will allow you to have each field marked as index. Databases, man, databases. And the whole thing, this saving and all of this done is via that storage engine. Yep, that is your guy. Junior CEO, you can say, which helps you to store all of this data indexes into the disk. So the more powerful your data storage engine is, the more powerful your database is. And this storage is actually done in the different data format because it's a structure. You want to store your data. And that's where you learn about the B trees and B plus tree. Anybody who is doing their master's or the PhD, once in a while in the computer science, they have to study these B trees and B plus trees, and even have to read the research paper of how we can optimize it more further and go beyond the B plus trees. There's hash index, there's a lot more. that happens. Now, coming back, now that you understand why the database are storing, having a war on this portion as well as on this portion, then comes the manager. Every database is trying to hire more and more managers, not literally hire, but you can say they are injecting more and more managers. The first, these are the common managers. There are more actually these days. The first one is the transaction manager. Now, the transaction manager is somebody who guarantees the transaction. A transaction simply means if it happens, then it happens. Otherwise, it doesn't happen partially. This transaction manager doesn't work alone. It actually takes help from other manager, but this is a guarantee because no matter what the database is, the transaction should be guaranteed. Like a lot of people says in the MongoDB, there is no transaction guarantee. No, man, you're wrong there. Absolutely wrong. The transaction is a guarantee and is a feature of database. Even if it's a MongoDB, either you save the entire data or you don't save it. That is the transaction. Nobody wants to have a database. Even database will not exist. A lot of people use database for their transaction history in the payment gateways as well. You don't want that, hey, sometimes it saves the data, sometimes it does. No, if it saves it, it saves it. It throws an error, then it throws the error. So transaction simply means a guarantee that it will store the data or will do a complete rollout and will give the error. That's the whole job. And how it does it is actually dependent on the lock manager. Lock manager does two things. If you want to write the data, it gives you exclusive access to that portion of the disk so that you can write it and nobody bothers you during that time, because databases, they are trying to use your computers a lot as much as possible. And if you know, these days everything is happen concurrently. Yeah, database is not like your JavaScript that it runs on single thread. They try to use as much as possible of your concurrency. But it is also required that the lock manager should give you a guarantee that if you're writing something, no two parallel process should come and write that. That's important. But if you want to read it, it actually allows the shareable read. So if somebody wants to read it, read operation should be faster. Otherwise, nobody will use the database. So read operations are shared and all the concurrent process can actually take and share the data. It does it through a lock table mechanism. So in case you want to learn that, I wrote it accidentally. I changed my pen. So in case you want to understand more about it, learn about lock table, simple process. There is nothing too much to discuss. And this is the interesting manager, which I love a lot about it. This is a recovery manager. Now, recovery manager is something really interesting. It uses a simple data structure, which is append only data structure. So if you have ever wondered that how the log tables are able to keep the track of all the logs that I'm making, because sometimes I mess up, but these logs are actually responsible to roll me back in the time. Yes, that's exactly the recovery manager is. It allows the database to have a point in time recovery that, hey, at this point of time, everything was correct. So through these logs and through this spatial data structure, which is known as append only data structure, you are able to go back in the time. Now, this append only data structure is not something new. It was always there in the logs. And in fact, the concept of how you're going to keep logs in database actually came to us only because of this append only data structure. And if you remember, what is an append only data structure? That means you cannot update it, you cannot delete it, you can only just keep on appending it. You can keep on adding on top of it. And that's, my friend, is your blockchain. Yeah, literally this is your blockchain. You cannot go back in time, you cannot append it, you cannot delete it, only the chains can be moved forward. So all those enthusiasts who say, I just care about the blockchain only, I don't care about logs or database. My friend, you missed the basics. It came in here from append only data structures. So again, this is really, really fun. Now, a couple of more things which are super interesting here. Right now, in the initial days, a lot of people actually had a competition onto this. All your utilities. So all your utilities, this is where a lot of people fought and said, hey, this is my SQL version. This is my SQL version. One or other of them try to give us more utilities and more control over recovery manager. That's it. That was the game. But these days, things are onto a different scale. There is a lot of debate and you'll find a couple of databases in this niche which are just focusing on the cache. Redis is one of them, which has like crazy cache power. And again, the same thing happens in the Redis even. There is no difference there. A lot of them are fighting over this storage engine, and a lot of them are fighting even what kind of data should I store and how should I store it and what metadata should I store it. So that's where you see the crazy war of the databases going on. All right, quite a long video. Not quite long, just 20 minutes. Again, for this much of the structure, it's 20 minutes. Again, this video is super helpful for somebody who is in early first year of their college and trying to get some interest in the MERN stack and finding why the database is so much powerful, or somebody who is not from the traditional computer science background and trying to jump into the things. This behind the engineering, behind the scenes is actually useful for them. And again, for those people who are enjoying these videos, if you're not going to share them on LinkedIn, it doesn't really motivate me that, hey, somebody is watching it, somebody needs these kinds of videos. Although these are very basic for anybody who comes from a computer science engineering, this is very basic. But I think it serves a good purpose. So share them up. It motivates me. And again, I think now I should go to sleep. It's almost 6 o'clock, so time to sleep. Okay, all right, goodbye, and I'll surely catch you up in another such video.